The United States is the country that spends the most on defense in the world, with a figure reaching 916 billion USD each year. But what few people realize is that a massive portion of that budget does not go into weapons or military hardware, but into the meals that sustain the armed forces. Every day, millions of meals must be prepared, transported, and served on time and to strict standards for soldiers who are training, deployed in operations, or participating in large-scale exercises across the globe. Behind each seemingly simple meal tray lies a vast logistics system, where kitchens operate like industrial production lines, and military chefs work under pressure no less intense than on the battlefield, where speed, precision, and food safety are directly tied to each soldier's physical strength. In this video, Mandarin Tech takes you to explore the logistics system that sustains the U.S. military, where military power does not begin with weapons, but with what soldiers eat every day. At military academies, the scale of meal service is so large that it operates like a factory. Each academy has thousands of cadets, and within just a few minutes, the kitchen must provide meals for the entire force. The people behind this system are not simply cooks. They undergo rigorous training, ranging from food safety to operating industrial equipment, and must pass a series of evaluations before they are officially assigned to kitchen duties. This logistical pressure is not limited to military bases. During exercises or training conducted outside established facilities, mobile field kitchens continue to carry out this vital mission. These mobile kitchen units are designed for rapid deployment in remote areas that lack basic infrastructure, such as access to the power grid, a stable supply of clean water, or proper storage facilities. Even under such harsh conditions, these teams must ensure the delivery of at least 2 hot meals per day for hundreds and sometimes thousands of soldiers on duty. The ability to maintain both the quality and quantity of meals in simulated combat environments is a key factor in sustaining troop morale and physical endurance. Though largely unseen, food logistics is an essential link in maintaining the strength and discipline of the United States military, the most powerful military force in the world. When food logistics is placed alongside the scale of U.S. military spending, its importance becomes clear. The United States is the country with the highest military expenditure in the world, and this figure reached $916 billion in 2023. When people think of that massive budget, most immediately picture giant aircraft carriers, stealth fighter jets, Abrams tanks, or secret weapons programs. Very few realize that a significant portion of the budget is allocated to something far more familiar and far more essential: soldiers' meals. In the military, a soldier does not fight with weapons alone, but also with physical strength, endurance, and resilience. These factors can only be maintained when troops are provided with sufficient nutrition at the right time and to the right standards. A hungry, exhausted, or energy-deprived soldier cannot operate advanced weapon systems, cannot remain alert during nighttime patrols, and cannot maintain discipline throughout harsh training. For this reason, food logistics becomes a core component of U.S. military power. Though it does not appear in the news on propaganda posters or in dramatic war simulation videos, this system quietly ensures the operation of the largest military machine on the planet. Every day, tens of thousands of military cooks, nutrition specialists, logistics personnel, and mess hall managers work around the clock to ensure that millions of meals are prepared and delivered to the right people, in the right place, at the right time. This is not light work. It demands speed, absolute precision, and an extremely high tolerance for pressure. And it all begins at the military academies, where logistical demands are pushed to nearly unrealistic levels. At institutions such as the United States Military Academy and the United States Naval Academy, the number of cadets often exceeds 4,000, equivalent to the population of a small town. And every day, this town must be sustained by a massive logistics operation. Kitchens are required to prepare between 10,000 and 13,000 meals, not including supplemental meals, ceremonial dining, special events, or takeaway rations for training units operating outside the main campus. This workload runs continuously, repeating day after day, with no weekends and no concept of off-peak hours. What is even more striking is the serving time. Cadets are given exactly 15 minutes to complete their meals, not 1 second more or less. That figure may sound simple, but in reality it represents an extraordinarily complex organizational challenge. Moving thousands of people into the dining hall, serving them, ensuring they receive adequate nutrition, and returning them to classrooms or training fields, all in a process that must run as smoothly as a perfectly synchronized production line. In an environment as demanding and disciplined as the military, even a deviation of 1 or 2 minutes can disrupt the entire day's training schedule. At the United States Naval Academy, the pace is even more extreme. More than 4,400 people are served in under 5 minutes. That means nearly 900 cadets receive their meals every single minute. No restaurant, no large hotel, and not even any civilian public food service system can operate at such a level. Only the military, with its iron discipline and meticulously optimized procedures, is capable of sustaining this tempo day after day. Behind this speed are kitchen teams working like precisely programmed machines. They must memorize every step, every position, every motion, know exactly when to replenish dishes, when to move trays, when to rotate shifts, and when to accelerate the pace. There can be no mistakes, no delays, and no missing items. And absolutely no cadet can be left waiting for even a few seconds. Because in the military, time is discipline, and even meals must obey that discipline. The environment inside military kitchens is extremely demanding. Temperatures remain very high due to numerous industrial appliances operating simultaneously. Chefs must work continuously to prepare meals on time for 4,000 people at once, operating steam kettles with capacities ranging from 60 to 100 gallons, large tilting skillets capable of cooking dozens of pounds of food, and multi-deck ovens running at full capacity. Food must be cooked in batches to ensure that it remains hot and fresh until service. Speed is a critical factor. Any delay, even by just a few minutes, can extend serving times. And this directly affects the training schedules of thousands of cadets. During periods of staff shortages, kitchens may rely on semi-prepared or pre-processed foods to maintain speed. However, quality must still be strictly controlled. Accidents and incidents in the kitchen can occur frequently, such as equipment malfunctions or chefs leaving the heat too high, causing food to burn. When this happens, chefs must find immediate solutions to ensure meals are still served on time. After hours of preparation in the kitchen, from pre-processing and cooking to portioning, the dishes are finally brought to the mess hall. The daily menu usually revolves around familiar military food groups: chicken, beef, fish, pasta, vegetables, bread, and sometimes rice. At many academies, the salad bar is an integral part, offering over 50 different vegetables and toppings to encourage cadets to maintain healthy eating habits and a balanced diet. The most popular dessert remains pastries, providing sufficient energy while adhering to military ration standards. Some dishes have become traditions over time, even becoming a signature of each school. The most famous example is the buffalo chicken at the Naval Academy, always served every Friday as a familiar ritual that every cadet looks forward to. Regarding serving methods, the military generally employs two main models. The first model is an industrial assembly line, where thousands of trainees line up and move through each station to receive their meals, all in a quick, uniform, and extremely orderly manner. The second model is unit-based eating, where food trays are placed on individual tables. Each company sits in its assigned position and serves each other according to its structure. Although the methods differ, the principle remains the same. All trainees must eat at the same time, within a fixed time frame. This is not only a logistical requirement for managing a huge number of people, but also part of a lesson in military discipline. Eating on time, in moderation, and absolutely no food is wasted. As you can see, maintaining an army is very expensive. So to replace this force, in China they have created robot dogs so they don't have to cook for them.
Leading China's new generation of combat robots is the Unitree B2, a robotic dog that's breaking records in both technology and performance. This model is an upgraded version of the earlier Unitree B1, which was originally designed for industrial purposes, capable of moving underwater, carrying loads up to 80 kilograms, and operating for 2 hours when unloaded. But with the B2, every specification has been taken to a new level. Weighing 60 kilograms, the Unitree B2 is equipped with a high-power drive system that generates 380 Newton-meters of torque, combined with a reinforced structural frame and a large-capacity 2250 Wh battery. Thanks to these upgrades, the robot can support a static load of over 120 kilograms, carry more than 40 kilograms while walking, or maintain 45 kilograms for over 2 hours of continuous operation. When unloaded, it can travel more than 20 kilometers and run for over 5 hours on a single charge. In terms of movement, the B2 reaches a top speed of 6 meters per second, can jump 1.6 meters, fall from heights over 1 meter while staying balanced, and climb slopes up to 45 degrees without losing stability. Real-world tests have shown that even on slippery surfaces, like floors covered in banana peels, the robot remains balanced. It can be pushed, pulled, or have logs rolled under its legs and still won't fall. The B2 can also climb stairs in any direction, upward, downward, or sideways, proving the impressive stability of its active balance system. Inside, the B2 integrates a LiDAR positioning system combined with depth cameras and high-resolution sensors, allowing it to scan its surroundings and recreate a full 3D map of the environment. This enables the robot to navigate terrain intelligently, avoid obstacles, and perform remote inspection tasks in both industrial and military settings. One of the most remarkable features of the Unitree B2 is its dual mobility design. It can walk on 4 legs or roll on wheels simply by swapping its lower leg components. With its blend of mechanical strength, spatial intelligence, and modular flexibility, the Unitree B2 stands as more than just a technological achievement for China. It's a symbol of a new era in autonomous combat robotics, where machines are increasingly taking on the world's most dangerous missions once reserved for humans. The emergence of the Unitree B2 is only a part of a larger picture, the robot revolution that China is gradually building. The country is currently intensifying tests of advanced combat robots, machines capable of precise shooting, agile movement, and enduring operation for many continuous hours. This is not just a single project, but a national strategy aimed at integrating automation technology into the military, where machines are gradually becoming the steel comrades of humans. The goal of these designs is not only to enhance firepower, but also to reduce casualties among soldiers and to affirm China's increasingly strong position in defense technology. In recent years, the country has continuously expanded its research and demonstrations, introducing a wide range of automated platforms, from gun-mounted robots and reconnaissance drones to surveillance aircraft. All of these efforts point toward one goal: to build a modern army capable of multi-layered and independent combat under any conditions. At the China Air Show, the combat robot dog model became the center of attention. With its olive green camouflage coating, protective mesh frame, and ability to rotate, climb, and maneuver on complex terrain, it showcases technological power while also sparking intense controversy. Many international experts quickly noticed the striking resemblance between this model and the famous design by Boston Dynamics. Although there is no evidence showing that China was licensed or independently developed it based on the original prototype, this similarity continues to raise suspicions about technology copying in the defense sector. And amid the escalating tensions between the United States and China, the appearance of these combat robot dogs is not only a technical demonstration but also a silent declaration of the ambition to lead the era of automated warfare. And then that ambition quickly became a reality. No longer limited to prototype demonstrations, China began testing combat robots equipped with real weapons, marking a bold new phase where technology doesn't just support warfare but becomes the soldier itself. In recent years, the country has unveiled a series of high-tech combat systems, from reconnaissance drones and surveillance balloons to armed robot dogs, symbols of a new era of automated warfare. In late 2022, a viral test video captured the moment a robot dog armed with a rifle was deployed by a drone. The UAV dropped the robot onto the roof of a building and quickly flew away. Just seconds later, the steel machine stood up, turned its head, scanned the surroundings with sensors, ready to open fire on any target within range. The weapon used by the robot was the QBB-97, a light machine gun with a bullpup configuration capable of firing about 650 rounds per minute, with an effective range of nearly 400 meters, using China's standard 5.8mm ammunition. Moving at speeds of up to 9 miles per hour, it can maneuver through narrow urban environments, quickly reach elevated positions, or reinforce defensive zones. When working alongside transport drones and infantry units, the system creates a three-dimensional combat model, operating from the ground, the air, and above, introducing an entirely new approach to controlling urban battlefields. Beyond mounting guns, many other robot versions are equipped with LiDAR sensors, laser scanning systems capable of generating 3D maps and detecting targets even in complete darkness. Some prototypes have already been tested in real-world conditions, demonstrating autonomous reconnaissance, rooftop positioning, and rear area assault capabilities. Yet, alongside these advancements comes a growing wave of concern. Questions about operational rules, control mechanisms, and legal boundaries are now at the center of global debate, as the line between human warfare and machine warfare becomes increasingly blurred. However, alongside that technological leap come tough, unanswered questions. Will combat robot systems become shields for peace, or spark a fierce global arms race in autonomous weapons? The growing presence of these machine armies is challenging everything we thought we knew about warfare. What do you think? Will future battlefields still be under human control, or run by emotionless machines? Drop your thoughts in the comments and follow us as we dive deeper into the future of war technology.